We have a ball that's being thrown up at 5 meters per second. We are trying to find the maximum height that it reaches and the time after which it comes back to its initial position. Let's draw a sketch. We have a ball that starts at point A. It goes up and eventually reaches this point B. The first part is asking about the maximum height that it's reaching, which is the height of point B. So we are trying to find this height, let's call it h. This is the first question. And the second question says the time after which it returns to its initial position. When you throw the ball up, after point B, it will start falling down. It's coming back to where it started, at point A. And we are trying to find out after what time does it happen. Let's start with the first part. We will start by writing the given information. We know the initial velocity at point A. Let's call it v initial is 5 meters per second. Since the ball is thrown up, and which is a vertical direction, and we know that in vertical direction there is the effect of gravity, and the acceleration due to gravity is 9.8 meters per second square. We also know that gravity always acts downwards, which is the negative y direction. Going up, y is positive, going down, y is negative. Since g is acting downward, it will be minus 9.8 meters per second square. At point B, that's the highest point, and we know that at this point the velocity would be 0. We are looking at the path of the ball from point A to point B. So A is the initial point and B is the final point. We call it V final at point B would be 0. And we are trying to find the maximum height, which is h. H is the distance traveled. So the distance traveled from A to B is our goal to find. Now this is A equals minus 9.8. Now, like I have talked before, these three formulas will solve most of the kinematics problems. We are trying to find D, and we have VI, A, and VF. Let's see which formula has VI, A, VF, and D. We have this one where we need T. The time is not given, so we cannot use the first one. The second one we have T and T square, which we don't know, so we can't use the second formula. The third one has VF, which we know, VI, which we also know, to A, we know the value of A, T is the only unknown. So we can apply the third formula. We have VF square equals VI square plus 2AD, and D is this height h, the distance traveled or the displacement. VF is 0, so 0 square equals VI 5 square plus 2 times A is minus 9.8 times D, which is the height h. This is 0 equals 25 minus 2 times 9.8 is 19.6 h. From here you solve for h and you get h equals 25 over 19.6 or 1.27 meters. So the maximum height that the ball goes is 1.27 meters. which is the height from A to B. We have completed part A. Now let's see the second part. After what time interval will the ball reach its original position? We have the initial velocity Vi equals 5 meters per second. We know that A is minus 9.8 and we are trying to find the time, and if the ball is reaching its initial position, at this initial position the height is 0 again, because the ball goes up and it comes back down to the initial position. And if you remember the definition of displacement, the displacement for path in question B would be 0 because the initial and final point are the same. So the displacement is 0. We need time. Let's look at the formulas again. Which one involves Vi, A, T and D? That would be the second formula, this one. Let's use that. D equals V initial T plus half AT square. Plug in the values. 0 equals 5T plus half minus 9.8 T square. 0 equals 5T. Half times minus 9.8 is minus 4.9 T square. From here, T is a common factor. T, 5 minus 4.9 T. And this gives us T equals 0 or T equals 5 over 4.9, which is 1.02 seconds. We have two different values of time. The first one, T equals 0, means the initial stage when the ball was just thrown. The moment the ball was thrown was T equals 0. That's when it was at A. And the second time, after 1.02 seconds, that's when the ball came back at this height again at point A. That happened after 1.02 seconds. So this would be your final answer, 1.02 seconds. This is how you solve problems in kinematics. I hope it was helpful. If you have questions, please let me know in the comment below.